Hi, everyone. I'm Natalie, and joining me today is Millie, Olivia, Symns. We'll do some more introductions in a second. But first, just in case you're wondering what you're here for. So we're doing, this is a workshop on NYC campaign finance network analysis. Just a word of warning, we had initially planned to do this as an in-person workshop, so we kind of had to alter things a little bit, but we're going to try and make it as interactive as possible. And we'll go through kind of how to, get you from soup to nuts for doing a campaign finance network analysis. Just a little bit of an agenda. So we're hoping to spend these first kind of next 10 minutes just doing some introductions, why network analysis, a little bit of background to R and the Rstudio cloud setup. You don't need to have anything downloaded on your machine to follow along, which is really nice. And then a little bit of background on network analysis. Warning, I am by no means any sort of expert on network analysis, and I don't believe that Millie is either, but that's kind of part of our intention with all of this, is we want to make this accessible and, let you know, if you're part of the RStats community, you know already that it's full of really wonderful, welcoming people, and you don't need to feel afraid if you're not quite 100% there yet. So we really want to encourage folks to just dive in and start playing around with code. And then kind of more towards the kind of meat and potatoes of this presentation will be a live code walkthrough analysis. And then we'll follow up with some additional data sets to explore in closing remarks. All right, but first, who are we? So as I already said, my name is Natalie O'Shea. I am a huge R stats enthusiast. I've been using R since about 2014, though I'd say most intensively within the past kind of 3-4 years. I've been very, very, very much in the R community, but kind of got introduced into R early in my graduate studies. I just started a job as an analytics consultant at a startup called BetterUp. So we'll be getting to do more work with people analytics, which is cool. And for anyone out there, shout out to all our CUNY folks. I'm a CUNY educated NYC transplant, came here via Iowa, but went to the Graduate Center to study biological anthropology. So that's a little bit about me. Millie, do you want to introduce yourself?
Yeah, hello everyone. My name is Millie. Super glad to have you all here today. So a little bit about me. I'm a data analytics person, researcher, and most focused on education, especially higher education. Done a lot of research on early college and the impact on students from underserved communities. I've been using R for about 3 or more years now. It was a tool of choice for doing data analytics or research at CUNY, where I also worked. And it's also the tool of choice for anything, for even my website today that I've recently launched. And I am a Brooklyn native for all my Brooklyn people. Shout out to you all.
Love it. Whoops. Just a little background on how Millie and I's pathways crossed, and I recommend you check out this group. Millie and I, while we just recently found out that our pathways have been crossing back into the past more than we realized through NYC Open Data Week. We both had attended some of the same events back when it was in person. But we came across each other again last summer at the Data Science by Design Creator Conference, which was a really, really wonderful conference, really focused on thinking about the future of data science and how we hope that the data science community evolves into the future. So if you're interested in this world and this kind of sketch stuff really excites you, definitely check out datasciencebydesign.org. We've got a really great community brewing there, and we'll also actually have an anthology coming up in the next couple of months, so keep your eyes peeled for that. All right, so you may be wondering why network analysis and not an expert in network analysis, but what got me interested? So I recently attended the Recurse Center, and maybe some of you have been, and I'm actually wearing my Recurse Center shirt now. Also mostly because I think it's the only green shirt that I own, despite being Irish. I just am not a huge fan of green in general, but I was like, okay, I got to rep my green shirt because it's the St. Patty's Day parade here in Sunnyside, Queens. And during this retreat, I worked on a number of different programming projects, and I'm an anthropologist, and I have a really keen interest in how social change happens. So network analysis was definitely something that I'd wanted to kind of play around with. So that was one of the things that I worked on during my time at the Recurse Center. And more broadly, I really think that network analysis can be leveraged for future diversity, equity, inclusion, belonging work. Right now we're really focused on kind of aggregate measures of diversity, but I think that network analysis into the future could really provide us with a way of understanding whether groups are very segregated, for instance, or how integrated are we, not just at an aggregate level, but really making sure that everyone feels like they belong within a space, and kind of being able to analyze that in some sort of way using network analysis. All right, so what is network analysis? Wikipedia defines it as the process of investigating social structures through the use of networks and graph theory. But more simply stated, you're really just looking at the relationships between people or organizations, some sort of entity, and creating some visuals and doing some analysis to represent that. We can do that with a little bit of data, some statistics, and graphing. So let's go over some of the terms that you're going to hear and see today. So Millie, I think you're up first.
Sure, yeah. So out of curiosity, if R as a tool is brand new to you, can throw into the chat, just like, newbie, first timer, what have you. So I know more or less how much I should go over things. But we will be using R. And for those who haven't or are not familiar with it, R is a programming language. It's used in a lot of ways. So you might hear us talking about like libraries or packages. This is just a way to, like, the way code is organized, and there are functions that we're going to be using from all these different packages. And we're also going to be working in a cloud environment. So we'll be working with R Markdown, which is like a plain text code, kind of like it's a special way that you can like see the code, but also notes there as well. And so we're going to be using all of that just so that you know at least some of the like language that we're going to be throwing at you. But so that you can join along in the work, I'm going to show you how to like set up our Cloud Studio if you haven't done that or haven't had that before. Here's a link to get to this page. We've created a repo so that you can have scripts that you can easily code along with us today if you so choose that journey. So
I volunteer as tribute.
Here is Rstudio, great company that also like has a lot of products that are helpful and coincide with R. And they have R Cloud, which is what we're going to work through today. If you haven't created one, you can get started creating one for free. You can do this with your email, a GitHub if you have one, or Google. I already have an account, so I'll sign in here. But either way, you can also try making an account with your email. So here, you see I have a couple of projects here, but if it's brand new to you, you won't see any projects here. But what we would like you to do today, if you'd like to code alongside us and start playing around with like creating your own social network graphs, you can start a new project. And with the new project, we'd like you to choose a new project from a Git repository. So what this does, and I will also paste this link in the chat.
Yeah, I got you, Millie.
Oh, you got it? Awesome.
Mm-hmm.
What it does is that it gives you a copy of all the files in the repository. So it's easily accessible. So you just do that and maybe like 20, 30 seconds at most, it'll create a project for you.
I'll also just chime in as this project is deploying, is that there's a lot of really great learning resources that you can actually access through this RStudio Cloud interface too.
Mm-hmm. Yeah, and so it brings you to this brand new RStudio environment. So just to give you like a quick tour of what you're looking at, on here we have a console. This is where you'll see, this is where you can run some code, but this is where you'll also see when your code runs action happening here. This is a file system. Here is the files that you will be looking at and working in today. And these are all the files that are on the GitHub repo at this time. You can change the sizes of these window panes too, if you'd like. And so what you will navigate to is this simple R Markdown file. This is where you'll find all the code that we'll be using today and some blank sections where you get to add your own code. But as Natalie's going through things, you can follow along and plug in here. So what would be good is to install the packages and load the libraries, and you can do that if you want to do line by line by like highlighting, doing Control Enter or Command Enter if you're on a Mac. Or you can simply, if you're in a chunk, which are these like gray boxes that start with this and end with this, see a little play button. If you don't want to figure out dealing with like shortcuts, you can also press the button and it will run everything that's in here. So when you see, oops, I did not set up. Let's see, awesome. As you see, things are happening here. But yeah, but that's a quick like tutorial on all things RStudio.
Awesome, thank you, Millie. Mm-hmm. So hopefully you're kind of going ahead and getting yourself into that RStudio Cloud with Millie's assistance. I'll kind of go through it really briefly and show you that setup. So if you missed something, you'll see me go through it as well. But I'm going to keep things moving a little bit.
If you have problems, you can also feel free to write it in the chat and I'll try to help you out.
Mm-hmm. Yes. So we've kind of got our RStudio Cloud set up. You should be hopefully kind of installing these packages. This shouldn't take too long. Again, that's included in your RStudio setup. So just a little bit of background on some of the social network terms we're going to encounter as I go through this analysis. So a node or a vertices is the plural, but basically these dots, these are simply the people in your network. And then the edges or these lines, these connections are the connections between people. There's a nice little built-in .com social network analysis thing that you can go check out for some very basics. Also, I highly encourage, if you're really interested in getting into the deep weeds with network analysis, specifically in this case applied to people analytics, this book by Keith McNulty is really great and goes through a lot of the statistics that you can actually explore using network analysis. So maybe I'll drop this link in the chat here, and it's available freely. So definitely check that out. Let's see. Okay, so yes, so today we're going to just go from soup to nuts, pull that data into the data frame or into R, analyze it, and we're going to do a couple of network analysis things. So we'll look at node centrality, which is just how connected individuals are to other individuals within the network. Specifically, we'll be looking at eigen centrality, which is how connected that individual is to other influential individuals. And this is a thing that's useful for figuring out who your kind of super connectors are within a network. And then we'll also use an algorithm to detect communities. So these are highly connected clusters of individuals. And this is just a way that you can kind of get a better understanding of what factors most influence community formation and things like whether communities are kind of segregated in the ways that you think they are. So you can kind of use network analysis to algorithmically determine communities, but then ground truth that with the communities that you think are existing, whether it's like certain demographics that you think are clustering together in certain ways. All right, so we already shared the GitHub repo in the chat, so that should be there. But we're going to go ahead and switch to our walkthrough. So again, if you're just getting started with R, you might, as you get into it, you're probably going to want to download Rstudio onto your machine and play around with that. But for now, we'll just use Rstudio Cloud. You can do get started for free and sign up. You can sign up using your email, or you can just use Google or GitHub sign up. So I'm going to use Google here. I'm going to select one of my Google accounts to sign in. So now we're at our workspace. Again, like I said, there's great learning resources here if you're new to R. So we've got these Rstudio Primers. Specifically, I'll just kind of point you to this iterate primer, because one part of what we'll be doing today is iterating through some vectors and using this kind of per package to actually calculate some of or figure out how different candidates are connected to one another. So if you want to get into the depths of that, it's a little more advanced. I would check out this Rstudio Primer. There's also great cheat sheets here. One of the most helpful that I refer to all the time is this data transformation cheat sheet. So I would definitely check that out. Okay, so this stuff always goes much faster than you think it's going to. So let's go back to our workspace and we'll quickly get started. So again, I'm going to go ahead and pull our GitHub repo here, and I'll just drop that in the chat one more time. And let's go ahead and start a new project from this Git repo. So we'll let that load. And yes, I see in the chat, the data is being read in JSON, but thankfully R is very good about, you can use either JSON or CSV. There's no, it just kind of depends on how you're reading in your data. With R Socrata on the back end, I think it does everything within JSON. So that's why I pulled from JSON. But if you use something like in R, you frequently use read CSV. That's another way of reading in your data. All right, so let's get started. So we've provided you with this simplified R Markdown network analysis, and we've kind of cut out some of the parts of the analysis to encourage you to code along with us, even though we have somewhat limited time here. So you can go ahead, hopefully you're here in your Rstudio project. And again, you can click on this R Markdown. So you're going to see that we have all of these packages that aren't installed yet. You can install them through this packages frame or panel right here. So we could do it that way. And then you can just look up, for instance, the tidyverse and install like that. But we're going to do it programmatically through this install. So let's just go ahead and click run. So if you're not familiar with R Markdown, let's run this chunk first too. Okay. Well, let's just click on the handy install button. R Markdown is very smart, and it knows what you're missing from your R Markdown file. So it'll often pop up that little error message that says, hey, you're using these packages in your analysis, but they're not actually installed on this machine. Do you want to install them? So that's really helpful. You can install that way. Again, you can install here. Or programmatically through a line of code like this. So we're doing our installs now. So while that's installing, I'll kind of talk through some of the next steps. So in R, you have what are called packages, and you have a library of packages. So your packages are what you're going to be using to actually analyze your data. And a few little tidbits. So I wouldn't, if you're trying to develop a really performant R script, you're probably not going to want to load something like the tidyverse in its entirety, but we're not really too concerned with performance here. So we're going to go ahead and just load in the tidyverse. But you can also pull specific functions from a package by simply naming the package. So we often use the dplyr package, and we can call a function directly in that way. And that allows us to not have to load in the entire library. All right, woo, okay, there we go. Now our installs are done. So let's go ahead and get started. So you can comment out that install packages so that it doesn't run again. And this allows us to load all of our libraries. So we're going to call the tidyverse library, the iGraph, and gggraph libraries. So let's go ahead and load those in. All right, so this is just some warning messages, nothing too major. So we'll skip over that. So next up, we want to load in our data. So let's call our data frame contributions because we're looking at the campaign contributions data. And just like I said, we can call actually there are a few packages that we need to load from here. So just really quickly, I think it only downloaded well, maybe it did. First, let's see if this works. Okay, so we're going to call from the rsocrata package. Usually it loads up a little bit faster. Maybe that's a sign that it isn't here, but we're going to do read.socrata. And then we're going to drop our open data set into there. So we can go to this link. So we can just drop this link in the chat, or Millie, if you could get that, that'd be awesome. And then we can access this via the open data set API by pulling this API endpoint here. So we're going to just copy this link. We're going to drop that here. So let's see. Yeah, so I didn't download the rsocrata, so you might want to run this frame. But let's just go ahead, and I think we're going to also need the network D3 package. So let's pull that in, rsocrata, network D3. Okay, there we go. So let's just install those really quick. Now we can actually load our data. Boom. Okay, wonderful. Good, that's working. All right, so while that's loading, one thing that's important from this data set on the open data portal is the data dictionary. So we're going to want to refer to that data dictionary. I've downloaded that already, so I have it here on my spreadsheet. And we can actually look at the different columns and see what we're actually looking at. So this just gives you some information about the column name, the description, and what everything means. So if you really want to dig into this data, you're definitely going to want to explore this data dictionary in depth and make sure that you're kind of looking at things. So for instance, we're not going to do this in this analysis, but you might be interested in looking at specifically labor union donations to candidates. You can do that by looking at the C code column and filtering it by this one specific EMPO acronym, which will pull only the labor union contributions. All right, so let's see. So now we've got our data. We can see that loaded in here. It's about nearly 85,000 rows of campaign contributions, all available on the NYC Open Data portal. So it just, again, shows you the recipient, what office they're running for. There's a code for that as well. That's important. The name of the person donating, or person or organization donating to this campaign, where they live. One of the things that I think could be an interesting analysis is looking at all of the campaign contributions coming from outside of New York City, for example. Who is trying to influence New York City politics that doesn't actually live here? I think is an interesting question. All right, so now we've got our contributions. Let's just do, just check some basic things. So we're going to, I want to be able to use the name of the candidate, not their ID, but I want to make sure that we don't have any duplicates. So I'm just going to do a really quick check to make sure that the length of our unique recipient IDs matches the length of the unique recipient names. So you can do that really simply by saying, first length, there we go, unique, and then we've got our contributions data set, and we can access the column that we're interested in by using this sign at, let's see, 205. So let's just copy that and do the same for recipient names and just make sure that they match. Yes. All right, so it looks like we're good to go. Both the ID and names match. So now we know, okay, we don't have any duplicates in the name. All right, so rather than completely coding this from scratch, we gave you some code to work with, but I'll just give you a little explanation here. So we're taking that big, huge, large contributions data frame that's nearly 85,000 rows, and we're going to kind of make it a little simplified because right now it's got a lot of data in it. There's a lot of columns that don't really have any information for most individuals. So let's just hone in on a data frame that's a little more succinct. I've explored this data in depth, so I know that there are individuals within this data set that have contributed to the same candidate more than one time. So what I'm doing here is that I'm just selecting the columns I'm interested in. I'm setting the amount column to numeric to make sure that we've got our column types correct. And then I have some filters here. So this C code filter right now, I'm not actually filtering anything out, but I included this as kind of some encouragement for you to potentially explore this data yourself. So you can say right now, I'm saying any C code that is within the range of that, for instance. Let's pull up our data dictionary really quick. EMPO and CORP, so corporations or labor unions potentially. I think they might be lowercase within the data frame. So I'm just going to check. Oh, no, they're not. So yeah, you could create a vector like that and only look at ones that are matching the C code P comp. So that's just something, like this is how you would do that. So I'm just putting these other filters in here for you to kind of explore that. The borough code here, again, you can look at different boroughs. I think in the dictionary, I think it's X for non-New York data frames or non-New York codes. Anyways, I'm not making much sense here, but let's go ahead and just run this and get our simplified data frame. Here I'm just grouping so that every recipient and name I'm summarizing so that we just see the total amount. So if I donate to, say, Scott Stringer's campaign 5 times, I just want the aggregate amount of my total contribution to that campaign. And then whenever we group by in R, we want to ungroup afterwards just so we don't continue to use a grouped data frame and later data processing steps and have some unexpected behavior. So as you can see, simply by aggregating those contributions, we've lowered by more than 15,000 rows in our data frame. All right, so now we've got kind of a more simplified data frame looking at exactly what we're interested in. So let's find individuals that contributed to more than one campaign or candidate, because we're really interested in understanding how different individuals or different candidates are connected to each other through their campaign donations. So what I'm looking for is did you contribute to both Scott Stringer's and Eric Adams' campaign? And I want to draw those connections so that we can see these communities that they would obviously align along like political boundaries, Republicans, Democrats, things like that. But there might be other interesting communities that form as well, simply on the basis of who donates to what campaigns. So we're going to call this the Double Dippers data frame. Double Dippers. All right, so let's take our simplified data frame. So this is contribution simple. And I'm realizing for some of you that maybe aren't familiar with R, this might be like just completely overwhelming. Just know that you'll understand it more with time. We're just kind of trying to take you again from soup to nuts on this analysis. So we've got our double dippers, or we're looking for our double dippers. We're piping our contribution simple data frame to our next step in our data analysis. This is a very common way to analyze data using the tidyverse. We create kind of data pipelines where each step is kind of progressively done on our data frame. So to get our double dippers, we want to group by the name, and then we're going to summarize our data frame. So we're going to summarize n equals n as a function. So this gives us, so for every contributor in here, we're calculating the number of times that contributor is mentioned in this contributions data frame. All right, and then we want to filter that because we're looking for our double dippers. So we only want individuals that have contributed to more than one campaign. So N has to be greater than 1. And then let's see, we want, just for making it a little easier to read, let's arrange our data frame in descending order of N so that our top contributors come to the top of our data frame and they're in order. And then again, since we grouped this data frame, let's just ungroup it so we don't have any unexpected behavior later. So hopefully this all kind of makes sense. I know I'm going through this quickly, but let's run that. So now we've got our double dippers. There we go. So we can click on that. We can take a look. We can see these are all of the individuals. This individual at the top here contributed to 21 different campaigns. So they're pretty prolific in terms of all of they're involved in a different campaign contributions. Actually, a frame. So what we're going to do here, and this is a step that we kind of pre-filled for you just to make it a little bit easier. And again, you can run this by pressing this play button. We're taking our simplified data frame and we're filtering it so that we're only saving contributions that come from individuals that contributed to more than one candidate. So we're looking for names within our data frame that are in this double dippers name vector, because this is, and all of them have contributed to at least 2 different campaigns. And then we just do some renaming to make the data frame a little easier to look at. And then I just want to highlight this step. So we're filtering our data frame. There's a lot of campaign contribution data in this open data set. So we kind of need to narrow it down to be able to say anything meaningful or look at anything meaningfully in this network. So we're going to only look at large donations for this analysis. But I would really encourage you, if you're interested in this, I think there's a lot of different ways to slice and dice this data that could be really interesting. So, I think the network that you're going to get coming out from campaign donations that are greater than $1,500 is probably going to be very different from the kind of network that you would get out looking at campaign contributions less than like $40. So that's kind of an interesting thing that you can hopefully build on and look at if you're interested. Okay, what's this network of like who receives really large donations and how are candidates connected to each other in these large donations? And then how does that compare to small donations? So I just use this as a jumping off point to explore different networks that exist. Let's go ahead and run that. I'm getting a little ahead of myself. Okay. Cool. So now we're looking at the first few rows of data and we can see the candidate, the person who contributed to that candidate, and then the amount that they contributed. So now we've kind of got the basics of our network data frame. This is really what we're trying to analyze. But we're still not done with our data processing. I'd say probably the hardest part of network analysis is just getting the data in a format that is amenable to network analysis. So let's go ahead and create our network data frame. This is probably the most complex area, and I apologize if you're someone who's new to R, this is going to look like a bunch of jibber jabber to you. But again, don't be intimidated. This is the kind of stuff that you just really have to kind of get into it, and it will start to make more sense as you do it. But let me kind of walk through what we're doing here. So I'm going to move this over a little bit so it's a little more clear. Okay, so now I create that network of shared donations. So again, and just to be like as clear as I can, because I know that this is a little convoluted, what we're really trying to map here in our network is we're making every single node or vertex in our network is going to be different offices. Now I can't think of any other office for some reason, but we're going to look at all of these candidates. We want to see what are the connections between the candidates, who is connected to another candidate through a shared donation from a common contributor. So the way that we do all the possible candidate combinations using this function. And then, so I'll just kind of, it's helpful, I think, to kind of like stop at different points and look at what step your data is in. So let's just run that first step. So I'm going to use I comment out the pipe there, so I'm preventing it from going a little bit further. So let's just look at what our data looks like right now. No, that's not the one I'm looking for. Oh my God, which one? There we go. Okay. Too many things named contributions. All right, so here, again, this is just giving us, well, let's transpose it because we want to make it into a long format to make it a little easier to understand. So these first couple of steps, taking those unique candidates, creating the matrix and transposing it to a long format gives us this nice set of candidate to candidate connections. So this is all of the possible connections. So this is Sean Abreu with every other possible candidate that has data on the open data portal in terms of campaign contributions. Okay, cool. So we have kind of this set that we're looking at. So these next steps, we're going to make a data frame, kind of rename these columns just because they're a little unclear. So V1, V2 isn't really informative. So let's rename those to from and to. And then this step here is the part where, again, I'm encouraging you to check out the primers and specifically the iterate primer and start to learn a little bit about the per package. So what we're doing here is we're counting the length of intersections of candidates from a single contributor. So again, what we're doing right here is this is filtering all of the contributors that contributed to our first candidate. So this is our from column. And then this is a list of all of our contributors, all of our contributors that contributed to the second candidate, the to column. And what we're doing is we're getting the intersection of those two sets of names. So we're saving only the ones that are in both of those candidate data frames. And then we're returning the length of that. So this is just counting, okay, 20 people contributed both to Eric Adams and Scott Stringer's campaigns, something like that. And then finally, we want to remove all of those rows that there is no overlapping donations, there is no connection between them, so we don't need that in our data frame. And then again, we're arranging this in order of descending order of shared donations. So I know that, again, a little complicated if you're not familiar with R, but I swear, just as you kind of get more familiar with R, this stuff will start to become second nature. Okay, cool. So here we have our real candidate network analysis. So again, I've explored this data, so I knew that Eric Adams and Scott Stringer, that's why they're kind of at the top of my mind, have the most shared donations. But we can see, again, all of these are different candidates and how many people donated to both of those campaigns. So let's go ahead, and now we're going to get back into it. So now let's create a very, very simple network graph. And this is really fun. It's not the most informative, but it's very pretty. So if you've been following along, you'll kind of get your little dopamine hit of fun data visualization stuff at this point. So let's take that candidate network, and it's really this simple. We're going to use the network D3 package. So again, network D3, that's how we call a specific package. And we're going to just create a simple network. And it's literally as simple as those two lines. And boom, you have this really cool visualization. So the network D3 package runs JavaScript D3 on the back end for you. It just makes it very simple for you to pipe your R data and create cool little interactive visualizations like this. So we can pull and see, okay, this is the Scott Stringer node. And you can kind of play around with it and see all of the other candidates that are connected to Scott Stringer. And then you can also see people that are on the outskirts of the network, right? So this Justin Brannon character is only connected to Richie Torres. So again, it's kind of a fun little way to just explore the network and just see what patterns exist. But we're not really analyzing the network here. So that's kind of the bummer of it. So we're going to go a little bit further, and I know we're kind of running down on time here. So we want to get to the network analysis part, right? But again, this is just so much fun to play with. So I encourage you to get to this step in the analysis if you can. All right, so again, we've removed some of the steps here to encourage you to code along with us. So let's create a graph object that we can actually analyze. So I'm going to call this graph data frame. All right, and then we're taking that candidate network that we built, and we're going to use a function from the iGraph package called graph from data frame. So you can just give it a nice little data frame that's set up the way that we just went through. And we're just telling this that it's not a directed data frame, so the order of from and to doesn't really matter. And this creates a nice little graph object, which the structure of it is a little complex because these graph objects are kind of complex. In these next 3 lines of code here, we're looking at different types of centralities. We're going to graph eigencentrality, but there's different ways that you can calculate a node centrality. Again, eigencentrality is specifically how connected an individual is to other influential connections. So we can use, again, more of these, I think these are from the iGraph package as well. These are just functions that take your graph data frame and they run these statistics on them. And then we're just passing them back to the data frame and we're setting them as vertex properties so that we can then graph them. So again, you can play around and look at all of these different types, but let's go ahead and visualize those. So we're going to use the ggraph package, ggraph package. I feel like I'm probably messing that up. We're going to pass it our graph data frame. We're going to give it a free layout, I think is what FR stands for. I'm not 100% sure. And then for those of you that are familiar with using R for like ggplot, it's a similar framework, the grammar of graphics, if you're interested in that stuff. So you're kind of layering on different aspects. So we've got our basic graph data frame, but let's actually add some geomes to it. So these are like the actual shapes. So let's do our geome edge link. And we'll make our links gray because we're boring and it's a rainy day out there. All right, and then we've got geonode point. So we've got our edges and our nodes that we're coloring here. And if you're familiar with ggplot, you're probably familiar with the aesthetic function. This allows you to set color to kind of be variable, or color or any property of your graph to vary along with the properties of your data. So rather than setting color to all of the nodes have to be gray, we're going to make sure that color varies according to the eigenvalue that we set with that eigencentrality. Also, again, there is a literal St. Patrick's Day parade outside my window, so just be expecting to hear bagpipes for the next couple of minutes while I go through this. All right, so let's scale those colors just really quickly. Scale color gradient while the bagpipes play in the back. All of our low values, we're going to set those to light blue. All of our high values, we're going to set to red. It's where we're getting so close here. We're so close to the end. We've almost finished our network analysis. We're almost there, just a couple more lines. Geonode text. So I want to actually be able to see the high eigenvalues. So I'm going to set my label to vary as if else. And if my eigenvalue is greater than 0.8, I want to print the name on top of my node. Otherwise, don't print anything. So just NA. And then we're going to do theme void. All right, so now we can actually run this and have some fun. Ooh, oh no, I ran into a problem. Uh-oh, what did I do? Well, let's just remove this for a second. Let me just make sure, see if this works. Yeah, okay, so I think I might have to set my eigen slightly differently, but again, we're running out of time, so I don't want to spend too much time troubleshooting this. But you can see that the nodes on the outside of our network are light blue because they're not really central to the network. But right here, this network, which again, because I've worked with this data a little bit, I know that that node is actually Scott Stringer. He's the most central person in our campaign contributions network. So if I had that labeled correctly, if I wasn't getting this error, that's what we would see.
You're just missing a parentheses in that line. Like
I am?
one more.
Oh,
yeah.
If else, which parentheses?
There's a third one in that same line.
Why
wait.
this?
Oh, it must be something else. Okay.
Well, this is the fun.
I pasted the code in the chat if you wanted to copy that too.
I didn't even change anything. Well, anyways, it should work. Here, okay, whatever. I don't want to get too caught in that, but we'll skip ahead and just go ahead and finish out because we only have a few more minutes together by detecting some communities. So we're going to use what's called the Louvain algorithm. And again, we don't really have to do anything on the back end because some other smart person came up with how to actually, calculate all of this using R. So we can just run this cluster Louvain on our graph data frame, and that calculates all of these communities based on where they sit within our network and who's connected to whom. And then we can, again, just like we did with eigencentrality, set that as a vertex property. And we can just quickly check the number and size of communities that were detected. So according to this algorithm, we have 4 different communities. The lowest being only 3 members of the community and the largest being 11 people in the community. And then, again, there's a parade happening outside my window, so I apologize. So let's go ahead and just quickly visualize this community. So I'm just copying that text from above, but I'm going to make a few minor adjustments here. Let's see. We don't need to scale the color. But we are changing this from color equivalent to eigen, and we're going to make this, we're going to set our communities to factors. So as a factor, community. And then let's see if the labeling works this time. So we're going to set community equal to 1 so that we map all the individuals in the first data frame. Oh, did I not? Oh, as factor communities. Oh, communities. Oops. Yay. I don't know if you guys can all hear that, but it's very wonderful out there. Okay. Oh my God, I'm running into, okay, well, I keep having trouble with this geom node text, so there we go. All right, this is where live coding can bite you. Because I'm like, what? All right, sometimes it gives you problems. I don't know what I'm messing up here, but I'm messing something up. But I will just note, just to make this a little end on this note, you can also run a little more. This is a full analysis with some additional stuff in the analysis folder. And you can knit this together and you'll see a whole, it's very distracting to try and do this with a parade happening. But you can see the full analysis with all of the kind of cleaned up code in there. So while I do this, let's see, I think we've taken it basically from soup to nuts, and we just want to end by kind of giving you a little network analysis inspiration. So Millie, I'm going to let you go ahead and take over and show some of the data sets that you found, since there's a parade happening outside my window.
Yeah, sure. Okay. So glad that you all are still hanging around, and I hope you got to get through some of the code and play around yourself. Oops. So what we wanted to leave you with, besides sharing how Natalie went about looking at the contributions data, we thought, it would be really great to give you all some inspiration from some other data bases or data sets in New York City Open Data. So there's this cool tool called Scout, they're having an event, I believe tomorrow. I can check if I can find the link. But Scout is this cool AI tool that helps you discover a lot of the data from NYC Open Data. because the platform itself might be like hard to find data sets. This makes it really easy to look for things. And another cool thing that you can do is create like your own collections of data sets. And that's what we shared with you today. So I'm going to drop the link to this collection. When you're looking for, I think like data sets to work with analysis, and other people, if they know more about this, can chime in. But you're looking for data sets that like have connections or actions between people. So like people like reviewing products, some example, or like voting or social media connections, how people are connected together in that. Here, looking at New York City open data, they're thinking about the to and fro for like taxi trips. And so how are these trips connected, if any at all, by the different taxis that are provided, or even community college expenditure, like by source and the amount. We've also added the campaign contributions. And so these are some data sets that you can explore. So this is what it looks like in Scout. You can see where all the columns are. There's a little bit of information about how often this is updated. If you were to expand this, this gives you like more insight of just like what other data sets in New York City open data is connected to this data set by this particular field. If you're so curious, so you can see the other data sets that match this if you ever want to join things. And if you ever want to view it in NYC open data, you can click the link, and just how you saw where Natalie connects to the API, you can find that link there and you can explore on your own. Yeah, that was all that we wanted to show you today. It was super great having all of you here. You should definitely keep your eyes peeled for the future of data science ecology by Data Science and Design. And this is their Twitter link here if you're curious about that. And here's some contact information for ourselves if you want to stay connected and continue this conversation.
Yeah, awesome. Thank you, everyone. Apologies for the parade happening outside my window, and thanks again to Millie for co-teaching this with me. I appreciate you all stopping by.
Yeah.